Department of Chemistry, Ideal College of Arts and Sciences. During COVID-19 pandemic period, our college launched online degree classes. In this connection, I want to take second year class, that is third semester syllabus. In inorganic chemistry, there are two units. First unit, theories of bonding in metals and chemistry of d block elements are there. And in second unit, metal carbonyls and chemistry of F block elements are there. Now, in first unit, I want to take this topic, theories of bonding in metals. And I divided this concept into three modules. This is the first module. Before going to the concept, why you are studying the bonding in metals? Because you already know that in the periodic table, most of the elements are metals, and metal have different properties, and also elements of S block elements and most of the D block elements are metals. What is a metal? How we define a metal? And you, before knowing the definition, you already know the properties of metals. Metals are very hard. They have very high boiling points and melting points. They are very good conductors of heat and electricity, and they exhibit the properties of malleability and ductility. They have definite crystal structure. They are sonorous. They they are luster. And one more thing, as the temperature rises, the conductivity of metal decreases. That means, without knowing the definition, we know the properties of metal. But what is a metal? Metal means which can easily lose their outermost electrons and form positive ions. That means in S block, suppose if you take an S block has two groups. One is first A and the other one is second A. In first A group, the first element is lithium, potassium, sodium, cesium, rubidium, and francium. Lithium, all are metals. From top to bottom, as the atomic number increases, the atomic size increases. At the same time, the ionization value decreases. So it can easily lose their outermost shell and forms positive ions. So do you understand this concept? Metal which can easily lose their outermost electrons and form positive ions. So why these metals exhibit this type of properties? If you know the bonding, then you can easily understand the concept. What type of bonding is present in metals? Experimental results from the study of the properties of metals indicate that the bonding in metals is entirely different from the ionic or covalent nature. Generally, in chemistry, the chemical bonds are ionic or covalent. But these two bonds are not present in this metal concept. The metal lattice positions of the crystal are occupied by identical atoms. So sharing and transferring of electrons are not possible. So the bonding in metal is a special type of bond. It can be explained by various theories. In your syllabus, three theories uh, are given. In the first, free electron theory is also known as electron gas model. Valence bond theory is also known as resonance theory, and band theory is also known as molecular orbital theory. First of all, the first theory, free electron theory. This theory was proposed by Drude and Lorentz. Metals have low ionization values. You already know that each atom in a metal is the sum of the valence electrons and form positive ions. And these positive ions are called kernels. And the um, lost electrons are delocalized. They move freely, randomly move toward the crystal. See, kernels occupied. Kernels means positive ions. Positive ions occupied closely fixed position, while valence electrons occupied in between the kernel. Thus, the metal was regarded as assembly of positive ions immersed in valence electron or gas. Hence, this theory was also known as electron gas model. Force of attraction between the kernels and mobile electrons, which hold the metal atoms together, is called metallic bond. And this theory explains mainly the thermal and electrical conductivity of metals. And what are the drawbacks? It does not explain semiconductors and specific heats of metals. It fails to explain why some metals have greater electrical conductivity than others. So this is module 1. I hope you understand the concept, free electron theory.